Here we have a MacBook Pro that's not turning on. This is an A1398 15-inch Retina. Let's take a look on the inside of it and see what's going on with this MacBook and see if we can make it work again. 19 milliamps and not turning on. Alright, let's turn on the good old multimeter, turn on the Paul Daniels software, pray that it works this evening, as we always do, and see what's going on with this machine. Holy moly, it worked on the first click. It's a Festivus miracle. PP Bus G3 Hot is 12.6, meaning it's not shorted to the CPU, which actually puts us ahead of most of the 3662 boards that I work on. Over here, we're going to see if when the board is out of the case, if it turns on. And it looks like we're still getting the same amperage usage that we were getting before, 24 milliamps. So we're going to take a look around this board and see if there's any evidence of anything that could possibly be causing this to be occurring. So we're going to go down our list of power rails the same way we do usually, and we're going to open up Flex Board View, and we're going to find the list of power rails. Remember, we have a problem with no power. So what I do, if there's a problem with no power, I'm going to go through and find the list of power rails in the machine, figure out which power rails are not showing up, and then we're going to chase why it's not showing up. You know, one of the difficult things to do getting into this, it's not even not wanting to do the work, it's not knowing what work it is you need to do. So I'm going to try and make that more obvious when we have these streams or live discussions. Now, as I've mentioned before many times, the G3 hot rails come on first, then S5, then S4, then S3, then SO. So we check PP Bus G3 hot, that was on. Now we're going to check the rest. Now we know that PP3V42 is on because I get a green light in the charger. Let's see if PPV G3 hot, PPV RTC G3 hot is present. It looks like it is. Present just fine. Now let's check something like PP5ES5. PP5ES5. That's 1.1 volts. Now 1.1 volts is not 5 volts. But one thing that's interesting here is that it's stuck at 1.1. Now remember the other day when we were troubleshooting this and we had an issue around that chip that makes the 5 volt and the 3 volt rails. What was going on is that we had power cycling. It was going between 22 and 36 milliamps over and over and over again. Whereas on this one, it's a steady state 24 milliamps. That tells me it's likely something different. I don't think it's going to be a short circuit anywhere in that area, but we are going to check out that area and see. That's still going to be my focus, but I'm going to focus on it from the idea that something else may be wrong with it. So let's just go over to that part of the board and see what happens around U7501. Alright, so we're at U7501. Now, right around this chip, there's going to be 3 enables, because remember, this chip is making 3 distinct different power rails. This chip is making PP5ES4, it's making PP3V3S5, and it's making PP5ES5. Since this chip is responsible for 3 different rails, it's likely going to have 3 different enable pins to enable each one separately. We have on pin 4, the enable pin that's going to be used to enable PP5ES4, right here. We have on pin 21 the voltage, the enable pin for PP3V3S5. And on pin 12, we have the enable pin for PP5ES5. So let's take a look and see what's happening here. So what I want to do is check 3 things. A, the voltage going into the chip at pin 23. I expect PP Bus G3 hot to be there. At this pin over here, pin 23, we should be getting 12.6 volts. The next thing I should be getting is enable on pin 12. And the third thing I should be getting is 5 volts on output and no short to ground. So what's what we're going to do? So let's take a look. So first thing I want to do is see if I'm getting 12.3 volts on the input pin right over there. So we're going to measure that first. There's quite a few pubes around there. .6 volts is going into it. The next thing I want to do is see if the chip is being told to turn on. So here, my light bulb, you know, the electricity is working. I got volt power going to my light bulb. Now I want to see if the light switch has been flipped. If we have 3.3 volts on pin 12, that's similar to the light switch being flipped. Remember, I can't blame the chip for the fact that the rail is missing, the same way I can't blame a light bulb for the fact that it's not emitting light if the switch is down. And here, the version of the switch being down is going to be that the enable pin of that chip does not receiving the power required to turn it on and tell it, hey, chip, turn on. Same way it's, once you flip the switch, light bulb, turn on. So let's see what we're getting over there. So on this pin, on pin 12, which is over here, according to my schematic and board view, pin 12, bam, we should be getting 3.3 volts. And we are. However, our output of PP5ES5 is still 1.1 volts. Now, when you look at this area, do you see anything interesting? Anything here that sticks out to you at all? It looks like this MacBook has had quite a few pubes inside of it before. You notice that there's many pubes. However, those pubes eventually turned into what looks like a smudge of egg salad or something over here. Gross. So we are going to remove the egg salad from this MacBook, and once you remove the egg salad from it, it may work. So I'm going to turn on my fume extractor. I have a HAKKO FA430 that I use for this because I don't want to breathe this stuff in. And I think it's really important if you work at a place that does this, that they get you a proper fume extractor. If somebody owns their own business and they don't use a fume extractor, if they want to ruin their own body and lungs, that's on them. But I don't think that a business owner's cheapness should be the reason that you're ruining your own lungs at work. So if you do stuff like this, tell your boss to get you a fume extractor. And if they don't, I would suggest opening your own business or finding ways to get in another business or quitting. Because that would mean that they value a few $100 in their bank account over your health and well-being. And I've noticed many businesses in this industry sadly tend to do that. And I'm not a fan of it. It makes me kind of sick. So what we're going to do here is remove this chip. This is a TPS 51980. I added a little bit of Amtech flux there. This is the quick 861DW hot air rework station. I believe that this is a 6 or 8 millimeter nozzle I've got on here right now. And this hot air station is available at store.rossmangroup.com, as well as the chip that we're about to put on here. So I'm going to find another TPS 51980. And if you aren't exactly sure where to get a chip like this, if you you're kind of confused as to how this works, U7501, which is a TPS 51980 on the 820-3662 board. And one of the things that you can do here, if you are able to browse over to store.rossmangroup.com, which is pretty cool in my opinion, a somewhat biased opinion here. Check this out, folks. Watch this. So you can type in 820-3662, and for any MacBook board, it'll actually show you all the chips that we have for that MacBook board. You just click there. Just bam. Everything. Backlight fuse that's compatible, LCD filter that's compatible, and what do you know? U7501, TPS 51980. And you click there, and it'll even tell you a list of the compatible boards that it goes on. It's just absolutely amazing. This is a one of a kind website that you can only find at store.rossmangroup.com. That being said, with our shilling being complete, let's find a TPS 51980 off of a donor board because I'm too cheap to use the chips that I actually sell to customers. We're gonna get ourselves a chip, and and we're gonna solder it onto this board, and it's gonna work. Okay, I've got my donor chip Now I'm going to tin those pads and prepare them for the new chip that I got here. So let's add a little bit of soldering flux. We're going to tin these pads. And then we're going to wick the pads. Now we're going to clean the board with an ESD safe sparkle paper towel from Amazon. That's an look at that ESD safe paper towel. Beautiful. Okay. Add some soldering flux and tin those pads beautifully and prepare them for a new chip. My wife likes Apple products in the Apple ecosystem. Thank you for providing a do-it-yourself Apple repair. With the money I have saved, I feel it is only right to give back to the information provider. Thank you, Lewis. Thank you, Awesome Robot. And thank you very much. I really appreciate that. And I really hope that whatever it was that you tried to fix, that it went well and you were able to solve your problem. And honestly, it's not even so much the money-saving part, although that's cool. There's something really cool about seeing the fan spin again on something that you figured out with your own brain. It's a really cool feeling, and it just doesn't get old. Like, there are many parts of the job that got old, but seeing the fan spin, the satisfaction of seeing the fan spin at the end never gets old. And I hope you enjoyed it. Okay. This is the wrong iron. So we're not going to be using the micro pencil today because it appears that my micro pencil tip is dead, and those things cost $55. I don't particularly feel like spending $55 at the moment. So, can I use toothpaste for flux and flux for toothpaste? What would happen if I did? Very bad things would happen, so I don't suggest doing that. So I'm going to make do with this tip over here. And use the angled edge of it to make sure that I'm getting into all the joints that I need to. Beautiful. This is obviously not the ideal tip for what I'm doing, but my other one broke, and I'd like to show you that even if you don't have the perfect tool for the job at the moment, that there are ways to improvise. I'm not saying that you should always use the wrong tool, nor am I saying that you should let a substandard job leave your facility. Just that every now and then you're going to have to use a little bit of ingenuity to make something work so that you can get work done, and that it is possible to, rather than saying, damn it, I don't have what I need, I guess there's nothing I can do. It's a happy little message of encouragement there. Okay, so we've replaced the chip and we've removed the potato salad from the board. Now that there's no more potato salad on the board, I'm curious to see if this board will function. So I'm going to rapid cool the board using rapid cool technology. Rapid cool technology. Okay, so we're going to turn off the rapid cool technology. Catch the board as it falls. And we're going to see if it turns on. Can I edit videos for you, says Rockford Tech. Well, I'd have to figure out and set up a way to actually send you video files. And one of the problems with that is that these files are like 50 to 150 gigabytes per board repair, and that I can't send that with Time Warner. Also, HAKKO, our store video editor, actually has something he'd like to tell you. There's that as well. So what HAKKO just said, so given that you would be replacing him and getting rid of his job. Now, if you're willing to work for cheaper than HAKKO, Mr. Yazudin. So now we're going to plug this thing in, see how many amps it's taking, and see if it turns on. Let's see if we get the magical fan spin. As you can see, the fans are spinning, which means that our work here is done. So the issue with this machine was that it was not turning on and it was taking 23 milliamps. Now, unlike the machine from yesterday where it was taking 23 milliamps and then spiking to 38 milliamps every time the other rails were coming on, this one was just stuck at 22 milliamps. 22 and what was happening here is our 5-volt rail was not turning on. And our 5-volt rail was not turning on because there appeared to be an abundance of pubes and also some egg salad right by our TPS 51980 chip. We replaced it. I showed you how we went about troubleshooting that, how we went out about finding the rail that was missing, and how we went about replacing that chip using tools that are all available at store.rossmangroup.com. And we've also got this beautiful water bottle here. I just have to show every single video. This is a water bottle that says schematics or die, featuring my kitty, Mr. Clinton. You can see that unlike the old merchandise I was selling, I've actually had his ass redrawn in this video, in this in this piece of merchandise here. So you can, as you can see here, this water bottle, unlike our old merchandise, has Mr. Clinton's ass fully drawn. So you can see the entirety of Mr. Clinton. The kitty that says schematics or die. This kitty asks you to support the right to repair. He's my cat. His name is Clinton, and he's featured on this water bottle. That's it for today, and as always, I hope you learned something. As I said, I'm going to try to keep up a daily board repair video from the queue, and with any luck, there'll be some lessons and interesting, useful tidbits that you could learn from watching.